And this lecture will focus as paragraph 2 on various forms of game theory and strategies. In particular, we will try to define and give various examples for the dominant technique or dominant method, pure and mixed strategy, Nash equilibrium, and prisoner's dilemma. Here, briefly, I would like to highlight what stands behind the dominant, pure and mixed strategies. As we mentioned before, the main components of game theory are players, so on, strategies, two, and payoffs or outcome. These are the determinants of every game theory. To solve various options of game theory, we use various techniques, including the dominant technique. The dominant technique based on elimination of strategies. As we mentioned before, for example, player A plays for maximum. That's he is known as the maximum player, while player A is player B plays for minimum. That's why we called him minimum player. The contents inside the cells known as outcomes. If the outcome is negative, for example -10, -10 if the gain for player B, but it is a loss for player A. From other hand, on the contrary, the positive values as usual for player A. If A is positive value, if 10 is positive value, it means 10 gains for player A and negative 10 loss for player B. Okay, so the summation of negative A plus, so the summation of gains and losses must equal 0 must equal 0. We will see in details the procedures of the dominance technique. The dominant technique also is based on 3 rules, and we will introduce with them in details later on. Okay. You know that game theory includes 2 strategies, or 2: pure strategy and mixed strategy. As usually in game theory, uses these 2 types of strategies. Pure strategy, it is a particular course of action that are selected by player. Particular course of action that are selected by player is called pure strategy. Each player knows in advance of all strategies out of which he always selects only one particular strategy, regardless of the other player's strategy. An objective of the player is to maximize gain or minimize loss. So this is pure strategy. If mixed strategy, on the other hand, it is a course of action are to be selected on a particular occasion with some fixed probability are called mixed strategy. And also, as you see before, we will make a stress on what is known Prisoners dilemma and Nash equilibrium. Please put into account and consider the following very significant statement. All models of game theory only work if the players involved, so the players involved in this game theory, are rational agents. Meaning that they desire a specific outcomes, operate in attempting to choose the optimal outcome. So they care about choosing the optimal outcome, incorporate uncertainty in their decision, and realistic in their option. So game theory is based on this statement, and I assume that this is a cornerstone of game theory. rationality of agents, the willingness of specific outcomes, attempts to choose the optimal outcome. So they are controlled by optimality. So they have to consider uncertainty in their decision, and they must be realistic in their options. So this statement is a guidance for game theory. Pure strategy. Strategy is the goals of action, and it could be pure or mixed strategy. Pure strategy: if the players select the same strategy each time, then it is referred as pure strategy. In this case, each player knows exactly what the opponent is going to do, and the objective of the players is to maximize gains or to minimize losses. Pure strategy also can be defined as when players select one particular strategy and ignore the remains or neglect the remains. For example, assume that the player faces three strategies: P1, P2 and P3, and he selected strategy 2. Then P2 equal 1, while P1 and P3 equal 0. As you know, the total of strategies must equals to 1. Okay, let's us highlight this strategy using the following example. This matrix shows two strategies for each player. Player A has 2 rows, that means has 2 strategies, while player B has 2 columns, that means he has 2 strategies. As known, player A plays for maximum. Player B plays for minimum. Now, to process solution for finding the optimal strategy, now focus on the first row and indicate the minimum value. So the minimum value in the first row equal 1. Let's move to the next row where the values are 2 and 3. So the minimum value in the second row equal 2. Okay. This operation concerns with the player A. Let's move to column. The biggest value in the first column is 2 and the biggest value in the next column is 3. The common value, this operation is known as row minimum and column maximum. Okay. Now, the common value between these strategies are 2. So we got 2 for columns and 2 for rows. So the common value between the row operation and the columns operation is 2. Then we select 2 as game value. This game value is placed in the intersection point between column 1 and row 2. This inside the circle, this 2 inside the circle, its place is in intersection point between column 1 and row 2. That's why we name it as saddle point. Saddle point is 2 and 1. 2 and 1. 2 indicates the second row. 1 indicates the first column. Accordingly, the optimal strategy for player A is 0 and 1. Why 0 and 1? Because player A chose the second strategy or the second row, not the first row. then the first row strategy equal 0. 1 means he choose the second strategy. One, it doesn't mean that he has a strategy in the second row. For player B, he doesn't care about the second row because two places in the first column, he doesn't care about the second column, but he cares about the first column because it's a place of the total point. So player B plays first strategy and ignore the second strategy. That's why the optimal strategy for B is 1 and 0. Let's see the second example for pure strategy. Given as usual two players, player A and player B. Given also 4 columns and 3 rows. That means player A has 3 strategies while player B has 4 strategies. Now we will start with the row minimum. To select the minimum value in each row. Row number 1, the minimum value is -5. Of course, -5 more than 3, less than 3, less than 1, and less than 20. For row 2, the minimum value is 4. 4 is less than 5 and less than 6. For row 3, the minimum value is -6. The maximum of all these minimums is 4. 4 in this case is called maximin. Maximin, the maximum of the minimum. Okay. Now let's move to column maximum. Now we have 4 columns. The maximum value in column 1 is 5. The maximum value in column 2 also equal 5. The maximum value in column 3 equal 4. The maximum value in column 4 equal 20. Okay, so the result of this operation is that maximin equal 4 equal minimax equal 4. This is the condition of the saddle point. The condition of the saddle point is maximin equal mini max. Okay. Now let's indicate the saddle point. Inside this rectangle, we indicated 4 as game value, because this is a common value between minimax and max min. The place of or the cell in which the game value is placing is known as the saddle point. Saddle point. The place row 2 and column 3. We can call it P23. P23. 2 denotes row number 2 and 3 denotes column number 3. So accordingly, the optimal strategy for each player is, for A is 2. What that means? That means player A will play the strategy number 2 and he will ignore the remaining strategies 0, 1, 0. He will ignore first strategy and the third strategy. For player B, the strategy is 3, column 3. That's why he will ignore column 1, column 2 and column 4. In case of pure strategy, the saddle point exists all time. Put into account this remark. In case of pure strategy, the saddle point exists all time. We don't need this condition in the mixed value. Mixed value doesn't require this condition, but pure strategy requires saddle point all time. So this is a pure strategy. Example number 2, please. Example 3. Find the optimum strategies of the player in the following games. Player A has 3 strategies. Player B also has 3 strategies, A, B, C. The first step is to apply row minimum. The least value in the first row is 20. The least value in the second row is 45. 45 is less than 50 and less than 55. The least value in the row C is 40. 40 is less than 58 and less than 42. So the maximum of this minimum is 45. Is 45. It's called max min. Maxi min. Now let us move to the column maximum. The maximum value in column A is 58. 58 more than 50 more than 25. The maximum value in column B is 45. 45 is more than 20 and more than 40. The maximum value in column C is 55. 55 is more than 35 and more than 42. The minimum of all these maximums is 45. Accordingly, the condition of saddle point is satisfied because there is a common value between row minimum and column maximum equal 45. So the game value equal 45. The saddle point, of course, the saddle point is 2 2 is 2 2. That means player A will choose the second strategy or B strategy, and also player B will choose B strategy. Okay. So, according to the saddle point. As we mentioned before, the saddle point is the condition of pure strategy. Usually it's difficult to find pure strategy or to solve problem with pure strategy without saddle point. Now game value equal 45, optimal strategy equal for A equal 0 1 0, and for player B equal 0 1 0. That's all. Mixed strategy. Mixed strategy is a set of strategies that a player chooses on a particular move of the game with some fixed probability are called mixed strategy. In this case, various strategies will be obtained. Assume that strategy B equal 0.65 and strategy P2 equal 0.35. Strategy P3 equal 0. That means the player will choose more than one strategy, putting into account the total of all strategies equals to 1, or 0.65 plus 0.35 equal 1. Now let's see more complicated examples to explain the essence of mixed strategy. As we mentioned before, firstly we have to check for the saddle point, and we mentioned before also mixed strategy doesn't require saddle point. If saddle point exists, that means we can solve the problem using pure strategy. Now, given the following matrix where two players are functioning, this matrix consists of 2 rows and 2 columns. Respectively, each of players has 2 strategies. Now let's check for the saddle point. The minimum value in the first row is 7, while the minimum value in the second row is 5. The maximum is 7. Moving to the column maximum, we found that the maximum in the first column is 9 and the maximum in the next column or the second column is 11. So the minimum of these two maximums are 9. So minimax equal 9 and maximum equal 7. So minimax doesn't equals to maximum, and thus no saddle point exists. Let's try the oddments model to solve it optimally. Let's move to which is known as oddments model to solve this problem optimally in the next slide. Okay, this is how to use the oddments and probability to solve the mixed problem. Oddments means remains remains. Or ends, remains, the remain of. So this is a copy of the previous problem where players face two strategies each. Now please focus and pay attention for this process. Let's start firstly with the row oddments. Check the first row. The oddment of the first row is the difference between the values in the next row. Please, again, the oddment of the first row is the difference between the value in the R2. That means R2, the difference between R2 is the oddments of R1, and we will state it there. Between high value and low value. That's why 11 minus 5 equal 6. So we replace the difference between values in R2 in the first row are as what? As R1 oddments. Now let's move to the oddments of R2. The oddments of R2 is the difference between the values in R1. Again, the oddments of R2 is the difference between the values in R1. That's why the oddments of R2 equal 9 minus 7. Nine if the value in the cell R1 and C1, and 7 if the value in the cell R1 C2. So the difference between them are 9 minus 7 is 2. Okay. Now let us move to the column oddments. Look to the first column. The oddments of C1 is the difference between the values in C2. C2 consists of two values. 11 and 7. So the difference between 11 and 7 is 4. 11 minus 7 equal 4. So let us move to the odd means of C2. The odd means of C2 is the difference between the values in C1. The values of C1 is 9 and 5. The difference between 9 and 5 is 4. 9 minus 5 equal 4. The next step, based on these arguments, we will find the probability of strategies. For R1, we call this probability P1. P1. P1 equal 6. 6 is the odd means of R1 over 6 plus 2 divided by 6 plus 2. 6 plus 2, it is a total of R1 odd means plus R2 odd means. 6 is R1 odd means and 2 is R2 odd means. So P1 equal 6 divided by 6 plus 2, it is 6 divided by 8. 6 plus 2 equal 8. So 6 over 8 equal 3 over 4. Divide each by 2. Let's move to the second probability, or P2. P2 also equal 2. 2 is the odd means of R2 over 6 plus 2. Please notice that 6 plus 2 is constant. So 2 over 6 plus 2 equal 2 over 8 equal 1 over 4. Okay. Let us move to the probability of player B. And started with Q1. Q1 is a probability for the player B. Q1 also equal 4, the odd means of C1, over the summation of two odd means. 4 plus 4, it is 4 over 4 by 4, it is 4 over 8. 4 over 8 is half. The probability of C2, which we indicated as Q2, equals 2. 4 is the odd means or C2. 4 over 4 plus 4 or 4 over 8 also equal half. So the first step again, the first step is to find the row odd means, and the second step is to find the column odd means. The third step is to find P1 and P2 as probabilities of for player A, and the fourth strategy is to find Q1 and Q2 as the probability for player B. Okay, now let us move to find the game value. Okay, we will use various calculations to find the same game value. Now, first, 9 multiply by 6 plus 5 times 2. Check. 9 times 6. Where is the 6? 6 is the odd means. Just look directly in the first row. 9 multiplied by 6. Close the brackets. Plus 5 times 2. This we calculate this operation in each row. So 9 times 6 plus 5 times 2. The summation of this, we will divide it over 6 plus 2. 6 plus 2. Okay. 9 times 6 equal 54. 5 times 2 equal 10. 54 plus 10 equal 64. Divided by 6 plus 2. 6 plus 2 equal 8. That means 64 over 8 equal 8. Okay. Let us try the next version. Look to the column C2. Look to the column C2. 7 times 6 plus 11 times 2. 7 times 6 is 42, and 11 times 2 is 22. 42 plus 22 is 64. 64 over 8 also equal 8. The third option. Okay. Look to the again to the row 2 or 5 times 4, let's check, or 2, plus 11 times 4, 5 times 4 equal 20, 11 times 4 equal 44, 20 plus 44 equals 64, over 4 plus 4, 4 plus 4 equal 8, and the result is 64 over 8 equal 8. The last, look to the row 1. 9 times 4 plus 7 times 4, 9 times 4 is 36, 7 times 4 is 28, 28 plus 36 equal 64, divided by 4 plus 4 or 8 equal 8. Perfect. Now let's move to our optimal strategy. For player A, the strategy is P1, P2. Return back to find P1 equal 3 over 4 and P2 equal 1 quarter. 3 over 4 and 1 over 4. Let's move to see the optimal strategy for player P. He has two strategies, Q1 and Q2. Q1 equal half and Q2 equal half. Thank you. Dominant strategy overview. The dominant strategy in game theory refers to a situation where one player has a superior tactic regardless of how other players act, holding all factors constant. That player enjoys an upper hand in the game over the opposition. It means regardless of the strategies employed by the opponent, the dominant always dictate the outcome. Dominant strategy asserts that the chosen strategy of an actor will lead to better results out of all possible strategies that can be used, regardless of the strategy that the opponent uses. Dominance rules. These rules deals only with rows and column. The main aspects of these rules is row and column. The first rule: the row having greater or equal corresponding entries will be dominating the other row. That means if the values of a certain row are greater or equal the values of other row, these rows will be dominating the other row. That means more greater or equal entries is dominated by the least values. Dominated means these rows which has maximum will be dominated. The column number 2, the column having less or equal corresponding entries will be dominating the other columns. What that means? Column C has less values than column B. If the values of column C is less than the values of column B, that means column B will be eliminated. In the case of row, if row B has biggest value than row A, then row A will be eliminated. Any row or column which dominated by other row or column will be eliminated. There is no such rule points to start the domination procedures with row or column. No, like this row. The main is the above rules 1, 2, 3 should be fulfilled. You can try with row or with columns, but inside the conditions of the rule 1, 2, 3. Okay, dominant strategy. given two players, player A has three strategies, R1, R2 and R3. Player B, two strategies, C1, C2. Now, the application of dominant strategy. Step 1. Compare the rows. Step 1, to compare the rows. So, compare R1 and R2, then compare R1 and R3 and R2, the last R2 is R3. Since the rules state that the preferable strategy is less or equal for player A, and the comparison shows that the rule is not fulfilled, thus player A has no clear strategy. Why? Player A has no clear strategy because the comparison between these rules, between these rows, is not, it doesn't fulfill the rule of the dominance. Okay, let's see. In this case, we will move to step 2 and see the comparison of two columns. Now, let's compare R1 and R2. -3 is less than -2, but 6 is more than 4. Move to the second comparison. 2 between R1 and R3. 2 is more than -3. Is more than -3, but 3 is less than 6. First, comparison between R2 and R3. In R2, -3 is less than 2, but 4 is more than 3. What do we mean by that? All values of R2 must be less or greater than the values of R2. Not one value is more and one other values is less. The unique all the values of R1 must be unique. What do we mean by unique? All the values is less or equal or more or equal than the values of R2 or than the values of R3. So when we compare R1 and R2, R1 and R3, R3 and R4, we found that the condition of the dominance rule is not satisfied. Now let's move to that means player A has no clear strategy. Now let's move to the comparison of two columns. Now C. Column C is more than column C2 is more than column C1, or column C1 is less than column C2. The values of C1 is less than the values of C2. Then according to the rules, the biggest value should be eliminated. Then column C2 should be eliminated. Okay. Player A has three strategies, 3 rows, and plays for maximum. Player B has 2 strategies, 2 columns, and plays for minimum. Pure dominant based on elimination of rows or columns. Now we will delete column C because column C is more than column C2 is more than column C1. Okay. Okay. Referring to the previous problem, column C2 will be deleted. Now player B has one strategy. Which concern with column C1. Player A had 3 strategies because he has 3 rows. Player A is said to be the dominant because he had 3 strategies compared to player B who has 1 strategy because of 1 column. And because player A plays for maximum, then we will choose because he is the dominant player now. And because he plays for maximum, then game value equal to optimal strategy equal A001 1 because the third strategy. Player A has 1 strategy but he is not dominant. In the first column 1 strategy, B1 0. This is about dominant strategy. Example 2. Player A has 3 strategies, or player B has 5 strategies. as we mentioned, it is not meaningful to start a comparison with columns or rows. Just satisfy the rules of dominance. This is a main requirement. Now let's look to the columns. C1, the values of C1 compared to the values of C2. Look at C1, you will see that 1 is less than 3, but 3 is more than 4, and 6 is more than 4 also. So the comparison between C1 and C2 doesn't satisfy the rule of dominance. Now let's move to compare C1 and C3. 1 is less than 2, 3 is more than 1, and 6 is less than 7. We will also ignore this comparison. Now move to the comparison between C1 and C4. C1 is less than C4 because 1 less than 7, 3 less than 5, and 6 equal 6. So C4 respectively is dominated by C1, or C1 is dominating C4. Therefore, C4 will be eliminated. Now, following the same process, let's compare C2 with C5. We remark that looking at C2, 3 is less than C4, 4 is less than 6, also 4 is less than 5. So C5 is dominated by C2 because the values of C2 is less than the values of C5. Therefore, C5 will be eliminated. There remains in 3 columns and 3 rows. Look to the arrow, the blue one. Now we got new matrix after the operation with columns. The matrix, which consists of 3 columns and 3 rows. Now let's try to apply the rules 4 rows. Compare array 1, array 2 and array 3. Check please if the values of R3 are more than the values of R2 or equal. 6 is more than 3, 4 is equal 4, and 7 is more than 1. Since A plays for maximum, R3 dominates both R1 and R2, because the values of R3 is more than the values of R1 and R2. Therefore, R1 and R2 will be deleted. The third matrix consists of one row and 3 columns: C1, C2, C3 and R3. Because player B has 3 strategies, C1 and C2 and C3, while player A had 1 strategy, and player B all time plays for minimum, not maximum. That's why we choose 4, because it's the minimum value. It is a minimum value because player B plays for minimum, while player A plays for maximum. We ignore player A because he has only 1 strategy, R3, and player B had 3 strategies, C1, C2 and P3. That's why we choose 4 as game value. Optimal strategies for A, he has no strategies, he has no first or second strategies, but he had the third strategies, so 0, 0, 1. For player B has 5 strategies, but he choose strategy number 2. That's why his optimal strategy is 0, 1, 0, 0, 0. Example 3. Let me remind you about the main dominants or the main rules of dominance. If the values of one row is more than the values of other row, or if the values of R1 is more or equal the values of R2, then R1 is said to be dominated, and respectively R2 will be eliminated. So if the values of row greater or equal the values other row, then the row with greatest value is said to be dominated value. If the value of column A is less than the value of column B, then it's said that column C is dominated column. Based on these remarks, let's apply the rules of dominance. It doesn't mind if we will start with column or row. Now let's compare row 3 with the remaining rows. Looking at row 3, we found out that the values of R3 is more than the values of R4 and more than the values of R1 and R2. R2 is said to be the dominated row. Therefore, R1, R2 and R4 will be eliminated. Now move to the comparison between column 3 and column 4. We found that the values of column 3 is less than the values of column 4. Then C3 is said to be dominated column. Therefore, C4 will be deleted. Now, based on this operation, R1, R2 and R4 will be eliminated and C4 also will be eliminated. The remain is one row R3 and 3 columns C1, C2, C3. Okay. The solution. Since player A has only one strategy and player B had 3 strategies, then the choice for player A and preferable strategy is minimum, as you know. Thus the game value is 4 and the optimal strategy for player A, because he plays for 3 0 0 1 0. For player B, because he chooses strategy 2, then 0 1 0 0. Again, let us discover the details of pure strategy. Given 4 strategies for player A and 5 strategies for player B. A1, A2, A3, A4 for player A and B1, B2, B3, B4, B5 for player B. Okay, now we are going to check for the saddle point using the principle of minimax and maximum. The first step is to apply the principle of minimum of flow. This principle is based on the selection of the minimum value in each row. So A1 row has 0 minimum value. A2, the minimum value is 4. A3, the minimum value is 2. A4, the minimum value is 1. Now, the maximum of all these minimums equal 4. The second step is to apply the same principle for columns, which is known as the maximum of column. The maximum value in column B1 is 9, in column B2 is 6, in column B3 is 4, in column B4 is 8, and in column B5 is 8 also. The minimum of all these maximas is 4. Then minimax equal maximum equal 4. Respectively, the condition of saddle point is satisfied and the game value equal 4. The game value equal 4. The saddle point is 2 and 3. 2 because of A2, 3 because of B3. So optimal strategies for players. For player A, he will choose the second strategy, then 0 1 0 0. For player B, he will choose the third strategy, respectively 0 0 1 0. That is all.